Yes, I am Lucy, and I'm here to talk about my team's work. So my team is called Conversation AI. And so some of the things I'm going to talk about are, first of all, I'll just give you some context on who we are, what Jigsaw is, what does our team do, what do we build, and then I'll kind of go into a couple different examples of how we're thinking about ethics in our data practices and in our product, and specifically with respect to mitigating bias. Okay, so Jigsaw is a unit within Google, within Alphabet, and we're building technology to make people safer. And it's a range of different things, research, products, thinking about digital attacks, online harassment, extremism, etc., many different things. My team focuses on the online harassment and hate portion, so that's what we'll talk about here. I'm not going to talk about any of the rest of the stuff. Okay, so Conversation AI is the name of my team's effort. Our mission is protect voices in conversation. And we do a range of different things. We build an API, we do research, we build tools around our API, and Perspective is the name of our API, which is really our flagship product. So what does that mean? Like, what does protecting voices in conversation mean? So we're thinking about how abuse, hate, toxicity in online conversation is actually forcing people out. Platforms are shutting down their comment section. People are just saying, like, I do not want to have a conversation on the internet. Specifically, voices are being silenced. People are not able to communicate, and people are forced to talk only. It's really, really hard to talk to somebody maybe who you disagree with online. So that's the area that we're working on. Those are the problems we're trying to think about. So what are we building? We're building an API that serves machine learning models to recognize various types of conversation that might actually be silencing people or forcing people out of the conversation. So you can send us a piece of text, like this example we have up here. It's going to go into our API, and what you're going to get back are scores for various different aspects of that text. And so about those scores, what we're modeling here is the emotional impact of that text. So we'll get to this later, but people often use this type of product to help their moderators know where to look. Those people are often enforcing a pretty complicated policy that represents, this type of thing is what is acceptable on our platform, this type of thing is not, and they're really detailed and really complicated and very hard to build machine learning models to support those things. So one of the core insights that we have working with this product is that all those policies are actually based on human emotions. They're based on how is this going to make somebody feel if they see it on my platform. And that's actually much more universal. People do have different feelings, but it's much easier to have crowdsourced annotations. People understand what you mean when you say, would you leave a conversation if you saw this? People understand that concept, and you can actually annotate data and build models off of that. So that's exactly what we're doing. This question here on the bottom, is this a rude, disrespectful, or unreasonable comment that would make you want to leave a discussion? That's what we call toxicity, and that's our main model that we're working with. So then on the team, there's a little bit about how we do our work. We're really operating all the way across the spectrum from gathering data, outputting doing machine learning research and publishing papers, building a concrete API, building tools on top of that API, and then working directly with platforms that use our API and even end users and people who experience harassment online. We really try to work that whole spectrum and understand what our impact is and where we can make a difference. So when we think about, are we being successful? These are a couple different metrics that we use, thinking about the participation in a conversation, how many people are able to participate, how diverse is that conversation, reducing the amount of toxicity that's forcing people out of the conversation. And then this last one, action, is thinking about how we as a team have influence on the industry and can influence the industry to take the problems of online harassment more seriously and respond even if they're not using us to do so. And so this is values. So when we started this effort, we actually sat down and set out a set of values. And when I say we, I was not on the team at this point, so other people's work. Community, topic neutrality, transparency, privacy, inclusivity. These are all really vague. They all are occasionally in conflict, and we actually talk about that a lot in our work, and we sit down when we talk about a new product or a new idea and think about how does this, reflect the value of privacy, and how can we think about that in our work? And you'll see that as we're going through some of the examples later on. And this is just more concretely, how do people use an API like this? So moderation is the kind of the most obvious one. Using an API to score comments coming into your platform, and then have your human moderators use that to sort how they look at them, know when to flag, really point them to where their expertise is needed. But that's not the only way you can use this. There's also authorship. So this is, as somebody is typing a comment, you can give them a little heads up, like, this might violate our community guidelines, or people often leave a conversation when you say things like this. And we've actually studied this a little bit, and it matters a lot how you give this message, but people do react. And it does actually make a difference, and we're really excited to see that. Then we're also thinking about readership or viewership. So imagine if you could give control to somebody who is reading comments and allow them to make a decision. Or even you can visualize different trends and study the conversation. Okay, so now I'm going to go into a couple little examples of how we're thinking about some of those values and the work we've done around them. Oh, my GIF isn't working. Okay, there's a GIF here, but you can't see it. So we have a public demo. If you go to perspectiveapi.com, you can actually see this. What should be in this box is somebody typing a nasty comment, and then you get back the perspective score. And so that's right there on our website. Anybody can try it. They don't have to set anything up, get access, pay, any of those things. And we found this to be extremely valuable. We're getting, we've actually had people will use that and point out problems in our model, and it helps us improve. There's even a way where you can say, hey, this model score is wrong, and we'll fix it. Not immediately, but we collect that information. We don't automatically train on that data, because we have seen people come to this and try to train our models incorrectly and give us bad data. And in fact, if you just take that data and have it relabeled by human annotators who you trust, it's actually really fantastic data for improving your product. But I can't stress enough how important it is to have a way for anybody to spot check what you're doing and really understand. It's made our product a lot better. And then another thing that we're working on is the concept of model cards. So a model card is a documentation framework that enables a product to sort of document how does their model work, evaluation results, how is it meant to be used, how is it not meant to be used, all of those things. So we have a version of this up on our GitHub. It's very preliminary right now, very kind of technically raw, but we're really excited to maintain this and build on it and think about how can we just hold ourselves accountable to sharing these results repeatedly every time we make a model update. Okay, all right, getting into the meat here. So thinking about unintended bias. So when we first launched the model, we had thought a bunch about unintended bias to begin with, and I won't cover too much of what we did before, only to say that we didn't find unintended bias in our model. Even though we were pretty sure it was there, we didn't know where. But through that demo that I showed you, right after our launch, people pointed out that we had problems like this. So what you're seeing here are several comments that are not toxic at all, but use words like gay, lesbian, transgender, and Muslim, names of identity groups that are attacked frequently online, and our model thought that those were toxic words. And so what we did to improve this is we actually looked at the data that we trained on, and we saw that, in fact, for many of those words, the data set, because it came from comments online, showed that those were toxic words. Those identities were so frequently attacked in online discussion that the model was correct in believing that they were offensive words for what it saw. So we actually needed to go outside of the domain of online comments to make a difference with this with this problem. So we added more training data, and we saw anecdotally from looking at how, looking at the model, like looking at what scores got back, it looked like it was improving. But we didn't actually have a way to really measure this concretely and test in a systematic way. We didn't have metrics, we didn't have data to test. So now I'm gonna dive into a little bit more technical stuff about how we actually measure for unintended bias and track how things are changing. So first of all, what do we mean when we say unintended bias? Here we're talking about models performing differently across different subgroups. And for us in this work, when we say subgroup, we're talking about identities that are being mentioned in the text. We could also be thinking about the identity of the author of the comment, the identity of maybe the person who wrote the article that the comment was posted under. We're not talking about any of that today. And then for us, because we have an API and the way that people use our API is very varied, we preferred metrics that were threshold agnostic. All right, so the AUC, probably most of you are already familiar with this, but we're gonna do a little review so that we can go past it. So AUC, it measures how good is a model at distinguishing toxic from non-toxic or positive from negative examples. So what you're seeing here in this chart, and we're gonna show a lot of these charts, so it's important to understand them. So the x-axis here is the model score, and this is essentially a histogram of how many comments have approximately that score. Red is the toxic comments, and blue is the non-toxic comments according to human annotation. So a model that looks like this is not doing a very good job separating toxic from non-toxic, so it's gonna have a low AUC. A model that looks like this is gonna have a high AUC, maybe exactly 1, because there's a lot of separation. You can actually just draw a line down the middle there and say, this is the division between toxic and non-toxic. Okay, so now to measure for bias, we're thinking about the AUC metric, but we're thinking about it divided up across different identity groups. So we have, and remember we're talking about identities that are mentioned in the comment. So on the top you've got the background, so all of the data, and on the bottom you've got just the comments that are mentioning a particular identity. And so and you can see this is biased, right? This model is performing differently for comments mentioning a certain identity. So we can measure this type of bias by measuring just the AUC on those comments that mention the subgroup. So we call this metric subgroup AUC. But this doesn't capture all ways that a model could be biased. So what about something like this, where if you look just at the comments that are mentioning a particular identity, you actually still can separate between toxic and non-toxic just fine. But where there's a problem is that the non-toxic things that mention a certain identity, those are getting scores that overlap with toxic things that don't. Your scores are too high. So you're gonna get, if you're thinking about false positives and false negatives, here you're gonna get a lot of false positives. So for this, we take the AUC of just the background positive or toxic things in the background section, and the subgroup negative, non-toxic things in the subgroup identity. We take the AUC of just those two subsets of the data. All right, and now the opposite. So in here we're thinking about a type of bias where within the identity subgroup, the scores are shifted lower. We call this background positive subgroup negative. Ooh, that's incorrect. Sorry. Should be background negative subgroup positive. Okay, and so we've got our 3 metrics, subgroup AUC, and then the 2 kind of crisscross AUCs. Then we created a synthetic data set where we actually just took templates and swapped in different identity words that we thought might be susceptible to bias. And so now we have a data set, we have metrics, we can actually test and see if that bias mitigation where we added data, we can see, did that actually help? And so what you're seeing here, I know this is very hard to see, but you're seeing those 3 different metrics for our first toxicity model and then our latest toxicity model. And the part that's highlighted, those are the identity terms homosexual, gay, and lesbian. So what you see is in the, basically, the darker boxes, those represent low AUC scores and essentially a high bias. So you're seeing a lot, and that middle column, that's the one indicating scores shifted higher. So we're seeing a lot of false positives, exactly what we saw in that original example. And what you see here is that it actually did improve. So we added data, we made an improvement. So that's pretty great, we were pretty proud. However, so we used that previous one, that was on synthetic data, really, really simple templated sentences. What we have here, we felt like those simple sentences were really helping us evaluate, but they obviously don't cover everything. So in April, we released a data set of 2 million comments. This is completely public under Creative Commons, so please go use it. And we annotated this for toxicity as we usually do, but we also annotated for identities. We actually asked human annotators what genders are mentioned in this comment, what races are mentioned in this comment. And that gives us a way to do that same type of division by subgroups mentioned, but not just focus on individual identity words by filling them into a template, but actually look at the overall concept. So that means that perhaps a comment talking about same-sex marriage might be labeled by a human as referencing the gay identity, even if it doesn't say the word gay. So looking at this data set, we actually don't see the same improvement that we saw. So these are the exact same models, just being tested on different data. And the results are much more confusing. You do see some variation. You do see that there is a reduction in that middle column in the identity labeled homosexual, gay, or lesbian, so any of those identities mentioned in the comment. You do see a reduction in the background positive, subgroup negative, or kind of false positive metric, but the other ones also some of them get worse. So much more mixed results here. So we dug into that to understand what was going on and what was the difference between these 2 data sets, why were we seeing such a discrepancy. And what we ended up finding is that if you restrict just down to short comments in the real data set, you actually see that the original model was performing even worse on short comments. So, and we saw that back, I didn't go into it in the original slide, but we actually saw that when we look at the data. Short comments that contain identity words are overwhelmingly toxic in online conversation. And so the model actually learns according to length. And so what you're seeing here, so this is showing that the problem was really, really bad for short comments. And that mitigation that we did, all it did was kind of bring short comments performance in line with the overall performance. But it didn't generalize and it didn't make an even broader improvement. So the takeaway there is there's a lot to look at here. There's a lot of different ways you can look at your data. And one way is not enough. And we're still kind of digging into, is this enough now? How do we want to prioritize that? This data set is public. You all can poke at it. I'm going to talk a little more about it. But please do. So this data set that we used there, we also released it in a Kaggle competition in April. I don't know if anyone participated in that competition. It was really fun. So the data is all there if you want to play with it. What we found, so in order to do a competition, where you're measuring models for their performance with respect to unintended bias. Obviously, you need a metric that captures that. So we took those 3 metrics that we had that I showed in the previous examples, and we actually calculate a generalized mean of those 3, and then average that also with the overall AUC to get a way for comparing models with respect to bias and overall performance. I think that is actually an area where we still would like to do more research. If anyone has other ideas and ways to think about this, I think, as I showed previously, like, one data set isn't enough, probably one metric isn't enough. So the concept of comparing models and trying to have a winner for least bias is pretty strange. So thinking about how can we actually do this in a competition format, or more importantly, when you're choosing for a product, like what is the model you're gonna serve, it's pretty hard to come up with the right metric, and that's an area we'd love to continue to talk about. And in terms of results from the competition, what we saw are, 1, BERT is killing everything. It's the hero. Every single winner used BERT, and it almost, like, there weren't other bias mitigation techniques that outperformed just using BERT, basically. So that was pretty interesting to us. The one bias mitigation technique that people did use was that they upweighted data that mentioned identities in their training. So similar technique to what we did, which was going out and finding additional data. They just upweighted the data that they had. And all of the winners did both of these things. All right, questions?
Along the annotation pipeline for toxicity. So specifically, like, how did you guys train raters to think about that question of toxicity? And do you have any statistics regarding rater agreement? How often did they agree, and how much of that was chance agreement?
Yeah, so we did a lot of research on this right when we were first getting started, and what I spoke about at the beginning is that question of, would you leave the conversation if you saw this? That's what we found worked best. That's what had the highest inter-annotator agreement. I actually don't have the numbers off the top of my head, but I can find them. But we found that the more you try to define it, the less agreement there is, actually, and that appealing to something that humans understand helps. We also do a lot of, we don't ask just one person. We, at a very minimum, 3 people, usually around 10 people. And we do that to capture that subjectivity. And actually, this is an area that we're kind of moving to think about a bunch more, is not thinking about the annotators as just like a black box, all the same person, because they're not, they're individual human beings. So with that Kaggle data, in the coming weeks, we're going to be releasing, as it is right now, what we have is the comment and then the percentage of people who said it was toxic. We're gonna release the actual annotator decisions. So each individual person's choice, hoping that you all will think about, maybe there's a better way to do it than just averaging. Maybe, some people are really good at rating certain comments, and we can weight those differently. So that's an area where I'm really excited to do more research.
Thank you for the talk. I'm curious whether you looked at contextual, like, the previous and following comments around a comment to kind of see the context that a comment came within, and whether that has any bearing whatsoever on the
So for the the product perspective as it is right now, we don't. So we're just looking at the individual comment. We have done some research on that, and we're exploring it further. Where we are now is that it does matter. The previous comment matters, the context of the conversation, it all matters in specific scenarios. So, there are a lot of really simple ways to be very toxic that are just toxic most places you go. And that's the majority of what's out there on the internet. But there are specific scenarios, and I think a lot of what we're researching now is it possible to narrow down to where context matters, and change our models in that way. So we're researching it right now, and hopefully that will change how we do things in the future.
For identity phrases that are less common, how much does annotation bias or annotation
Yeah, so I don't know. That's one that's pretty hard to measure. We've done a little bit of research on it, and I think it's pretty similar to the context question, where for the majority of comments out there, the identity of the annotator doesn't change what they're gonna say. But it's probably a very specific minority of comments where maybe not just identity, but an individual person's background knowledge, history, etc., matters and changes who is most prepared to accurately rate a comment. I think, again, this is something that we're looking into researching in the future and thinking about how do we best match an annotator with the data that they are best suited to rate, because we still don't know.
So when we look at the false positives, false negatives, what do you feel that needs to underline sort of behind why you model this kind of does it have to decide how to people might say or focus on something like that? When a certain person about the model?
It's very aligned with what you would expect from society. So identities that are marginalized, identities that get a lot of attacks online, that's where the model is performing badly. That's where the model is confusing those identities for toxicity. And we do see a little bit of the reverse. So identities that are generally in power, sometimes the model confuses those for lack of toxicity, and is bad at recognizing toxicity when those identities are mentioned. So it's actually relatively predictably aligned with the world.
You mentioned that this toxicity in shorter comments. Does the data have threads a long running conversation, and does that kind of increase toxicity in both parties or engage in, or is it more one-sided?
We've only done a little bit of research on this, and it's not my work, so I hope I get it right. But what we have seen is that, so we haven't done it too much in, as I answered previously, we haven't done a lot of modeling of an entire conversation and thinking about how that impacts bias. But we definitely have seen that toxicity does tend to escalate in a conversation, and that there are it might be possible to pinpoint a turning point somewhere in a conversation where the toxicity is starting to elevate, but it's not quite at the leave a conversation level. So more research needed there.
A follow-up question is, are any data sets localized, or are they all English or
Yeah, so everything here is English. We're really heavily invested right now in building this out in many languages. I believe we're soon to share the synthetic data sets in multiple languages. Again, we're building that pretty simply on our side. If there are, lists of identity terms out there in the world for different countries, that's input we would love to have and we are searching for. But we're starting with what we can get. And I think we'd also love to internationalize this larger data set. So stay tuned there. And if anybody has a large set of comments in any language that they want us to annotate, we would love to do that.
For the, if you actually work in different countries, it wouldn't be beyond the language, but also just cultural. Are you thinking on annotators to be from those specific regions? Do you think the API right now works fairly well in the US, but maybe not so much in other parts? Or what's your point there?
Yeah, that ties in with the research that we're planning around how do different individual people annotate and what of their background matters for how they make decisions. Definitely true that different areas, different countries language isn't the only thing that matters when we're thinking about bias. We also need to think about the society. All of that is super important, and we are thinking about that. I had another point I was going to say, but I forgot. One of the really cool things that's happening now is with BERT, there's a lot of work on multilingual models and models working, you don't necessarily need a different model to do multiple languages. And so rather than necessarily needing a different model for each different country that speaks the same language, so an English model for the US, an English model for Australia, one for the UK, etc. Hopefully, my hope is that if we have representative data going into that model from those different areas, that a single model might be able to do a good job with those things. And then, of course, we'd need to do thorough evaluation to spot check that it actually is. But that's my hope.
Do you also analyze the context around the comments, like either the preceding comment and after maybe a thread?
That question was asked already, but yeah, that we don't for perspective as it is today, but we have done some research on it, and where that research is leading is that many cases it doesn't matter, but in a small set of cases it does.
So like some hate groups like substitute words for other words. You guys take that into consideration?
Yeah. I think that's hard because often annotators are not part of hate groups, luckily, and so they won't always know that. So I think the key for us is monitoring, finding out like where is that happening and how do we spot it in our data in a way and make it correct it when maybe we don't necessarily believe that the annotators will know and be up to date with that language. We're definitely still working on how do we stay on top of that. But my hope is that similarly to how people use identity words or even reclaimed words, that a single word can have many different meanings. So taking one word and substituting it out for another word, a model can understand that. And it can understand based on the rest of the sentence whether you're trying to be hateful or not, even if it's a word that has many different meanings. It's a matter of making sure that the input data to train that model has the right labels, and that the humans who trained that model and the annotators who created that data can tell the difference themselves.
A two-part question. One was all the data sets you have written. Is there any difference if you were to get a spoken conversation and then look at a transcript? And kind of related to that, so annotators can you use, for example, if you have video or audio, can you use things like the tone and all that to organize signals for annotation?
We have not done that, but perhaps you could. I think it is definitely true that spoken language and written language are different. So I think some folks actually have tried running our models on transcripts of various audio, and it'll find the really offensive stuff if it gets transcribed correctly. That's another. I used to work on speech recognition and sidebar, but for speech recognition, it's a really big problem if you say something offensive that the person speaking didn't say, if you transcribe something offensive that wasn't what was intended. So the recognition is always going to err on the side of a less offensive statement. Same with machine translation. So when we incorporate those models into what we're doing, we actually can miss things if they get lost in the transcription or the translation.